A failed private rescue leaves NASA's SWIFT telescope on course for an uncontrolled return to Earth. This is Fascinating Frontiers, episode 175. A private spacecraft could not capture NASA's SWIFT space telescope, leaving the observatory to re-enter naturally. Details on timing and location remain limited while teams assess the orbit. SWIFT has operated for nearly 2 decades, delivering gamma-ray and X-ray observations of transient events. Engineers continue to monitor the spacecraft's systems until the final descent. The mission's long record of burst detection stands as one of its primary legacies. Now on a different note, Japanese researchers examining data from the Subaru telescope's 8.2-meter mirror found Comet 28P/Nujmin had passed through existing frames at just the right angle. The geometry allowed them to measure the comet's surface properties directly. The Subaru images captured reflectance data normally hidden by dust and gas. The work forms part of a larger effort to understand why some comets and asteroids share similar traits and what those similarities imply for solar system formation. Follow-up observations will test whether other naked comets can be characterized the same way. Point a radio dish at nothing for 1,000 hours and you still might miss the moment when an 8.2-meter mirror records the surface of a comet only a few kilometers across from hundreds of millions of kilometers away. In the Subaru archive, the nucleus of 28P/Nujmin crossed the field at a phase angle that sent sunlight straight back from bare rock instead of scattering through the usual dust shroud. That brief window yielded reflectance measurements normally masked by the coma, showing a surface whose spectral signature resembles certain asteroids more than typical active comets. The geometry lasted only minutes in the dataset, yet supplied the exact illumination needed to separate intrinsic rock properties from the surrounding cloud of ice and dust. Such alignments occur when the comet's orbit and the telescope's pointing happen to intersect at the right moment, turning routine survey images into unplanned surface studies. The discovery raises the question of whether other dormant comets hide similar asteroid-like exteriors that only become visible under equally rare conditions. We still do not know whether this naked appearance marks a common end state for comets that have shed their outer layers, or whether it identifies a separate population formed closer to the Sun. Shifting focus to laboratory work, University of Hawaii at Manoa chemists identified faster routes for large carbon-based molecules to assemble under space conditions. The findings address a long-standing question about how the building blocks of organic chemistry grow in interstellar environments. Laboratory simulations showed reaction sequences that operate on shorter timescales than previously modeled. The team traced specific reaction pathways that produce complex aromatics without requiring extreme conditions. Next steps involve matching the laboratory signatures against spectra from star-forming regions. On another front, Stanford researchers built a model showing how close-in lava-covered planets can retain atmospheres despite intense stellar radiation. The work questions earlier assumptions about the cosmic shoreline that separates worlds with and without atmospheres. Observations of these extreme cases provide new tests for atmospheric loss theory. The simulations incorporate surface outgassing balanced against stellar wind stripping. Follow-up spectroscopy will check whether the predicted retention holds across additional targets. Lava-covered exoplanets close to their stars are somehow keeping atmospheres that models once predicted would be stripped away. Stanford's new simulations show that surface outgassing and stellar wind interactions can balance each other in ways not previously calculated. The result forces a fresh look at which worlds might retain the gases needed for further chemistry. Observations of these extreme cases now serve as direct tests for atmospheric retention theories. What surface or magnetic process actually tips the balance on these extreme planets? Turning to human health in orbit, a new study isolates possible mechanisms that cause astronauts' lower eyelids to lose tone after extended time in microgravity. The changes are associated with shifts in vision that some crew members report. Researchers examined how fluid redistribution and tissue response interact during orbital flight. Data from multiple missions will help refine countermeasures for future long stays. The findings point to specific physiological responses that differ from those seen in short-duration flights. In other news, STARMUS Festival co-founders Sir Brian May and Garik Israelian presented the 2026 medal to filmmaker Sir Ridley Scott. The award recognizes his film's role in bringing science and big questions to wide audiences. Scott's latest project, Dog Stars, premiered globally before the ceremony. The medal has been given annually for a decade to honor science communication through creative work. Recipients are chosen for their ability to connect complex ideas with global viewers. Moving to personnel changes, NASA astronaut and physician Jonny Kim is returning to active military service after completing one spaceflight. His departure reduces the active astronaut corps by one member with both medical and flight experience. Kim's NASA tenure included training and operations support in addition to his mission. The agency has not yet named a replacement assignment for his former duties. His background as a medical doctor added specialized capability during his time with the Corps. Finally, NASA Science published a series of stories detailing the Sentinel-6B ocean surface topography mission. The articles cover instrument performance, data products, and the satellite's role in tracking sea level changes. Sentinel-6B continues the long-term record begun by earlier altimetry missions. Public access to the new materials begins immediately. The documentation highlights how the satellite contributes to climate monitoring efforts worldwide. Keep an eye on follow-up spectroscopy results for those lava world atmosphere models. That's Fascinating Frontiers for today. If you enjoyed this, a rating or review on Apple Podcasts or Spotify really helps new listeners find the show. I'm Patrick in Vancouver. Thanks for exploring with me, and I'll see you next time. And if you'd rather watch than listen, find us on YouTube at NERA Network. Links in the show notes. Quick tip from the network. Try the Do Positive Pod next. Good news in science and tech, plus one concrete action you can take. Every NERA Network show is free at neranetwork.com. Want the written briefing with source links? Each show keeps a summaries page on neranetwork.com. Scannable, dated, and free. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own.